Okay, let's begin. So by now, have you guys got used to my accent? And people says, okay, some people say, when you listen to Al Gore, the previous vice president, right? And it makes you feel English is your second language. When you listen to President Bush to speak English, it makes you feel English is his second language. And do you know what is my dream, my American dream of the speaking English? My American dream of the speaking English is to speak English as well as President Bush. Is my role model. Okay, some guys have trouble with using the calculator to find the cotangent and the inverse cotangent. For example, if you want to find the cotangent of 20 degrees, and if your calculator does not have the key for the cotangent, you may use the inverse of the tangent to find it. So you may first input 1 and divide by tangent of the 20 degrees. So this is how we find the cotangent function value. And for the inverse cotangent, is a little bit complicated. We listed some identities between the inverse cotangent and the inverse tangent. Depends on the sign of the x, right? So we have such identities about the inverse cotangent and the inverse tangent. Remember this. Inverse tangent of x. This guy, if x is positive, then it's equal to inverse tangent of the 1 over x. So when x is positive, and when the x is negative, this inverse cotangent of x is equal to inverse tangent of the 1 over x plus pi. So when the x is less than 0. And when the x is equal to 0, then you just simply get half pi. Right? And this is how we find the inverse cotangent. Remember these identities between the inverse cotangent and the inverse tangent is very important. And also, we have another identity between the inverse tangent and inverse cotangent. That is simpler. You have the inverse cotangent of x equal to half pi minus inverse tangent x. So that means you may just first find the inverse tangent of x and then use the half pi minus this inverse tangent of x, then you get the inverse cotangent. Okay? And let's look at the problem 54. On the page, let me see, is the 488. So some guys have trouble with this problem in your quiz, okay, in their quiz. So it's about the height of a balloon. It says a hot air balloon is between the two spotters who are 1.2 miles away. And one spotter reports that the angle of the elevation of the balloon is the 76 degrees, and the other reports that it is the 68 degrees. Now, what is the altitude of the balloon in miles? Okay, let's look at this problem. Okay, so first let's draw a sketch to illustrate this problem. Here is the balloon, and here we have the two spotters. And this spotter says the angle of elevation is the 76 degrees. And another spotter says the angle of elevation is the 68 degrees. And these two spotters are 1 mile away, okay, apart. So you have the 1.2 mile between these two spotters. So now we need to find the altitude of this balloon. So that is this guy, right? Let me call this H. So actually, when you draw a perpendicular from this point to the bottom line, you just form two right triangles. Let me call this A, B, C, and this is D. So you have the two right triangles. One is the triangle ADC, right? Another one is triangle BDC, okay? And in these two right triangles, we may first find the AD and then find the BD. And you know the AD plus BD is equal to 1.2 miles, right? So in this way, you can set up an equation in the unknown H. So let's first use H to find the AD and BD. In the triangle ADC, okay, to find the AD, what function should I use? What function? So if you do not, if you do not like the cotangent, you may just use the tangent, right? So you have the tangent of the 68 degrees is equal to opposite over the adjacent. So opposite is H, right? And the adjacent is AD. So now you multiply both sides by AD and divide both sides by tangent 68 degrees. Then you get AD equal to H over the tangent 68 degrees. Okay? And similarly, in the triangle BDC, you have the tangent of the 76 degrees equal to opposite H over the adjacent BD, right? H over the BD. Then you multiply both sides by BD and divide both sides by tangent of the 76 degrees. Then you get BD equal to H divided by tangent of the 76 degrees. And now you add this two, you get 1.2. right? So let's set up this equation. You have the h over the tangent of 68 degrees plus the h over the tangent of the 76 degrees equal to 1.2.